Okay, so this semester we've talked about different functions in this class. And so one of the things that scientists and mathematicians want to be able to do is model the data. So they go out and they collect a bunch of data. Maybe they're doing, I don't know, temperature and dates or something like that, as it gets hotter and the temperature or something, I don't know. Some kind of data they're getting anyway, some kind of relationship or ordered pair. So over time, maybe they see, oh, it's getting hotter, on the earth than it used to be, right? They talk about global warming and such things. So they've done that based on some data. Okay, so to do this, they make what's called a scatter plot. So maybe you have some data, and you find that it graphs all these individual data points. Those are each one data point, and you find it looks like this. Okay? Well, then you have to say, what does that look like? What type of function does it look like? Turns out this is an exponential model. That's what an exponential model would look like. And so you're thinking about y equals ab to the x, where a is greater than 0 and b is greater than 0. But you could also have the data look something like this. Lots of data points, and sometimes they use a lot of data points to get this information. This is also exponential, but a is greater than 0, but b is between 0 and 1, right? So we talked about those models. Now I'm going to have to try to fit 6 of these on here. You could have data that looks like this. Kind of, it goes up quickly and then it kind of starts leveling off. That's a logarithmic function. Okay. It's a natural log function. Anyway, and a is greater than 0 and b is greater than 0. And then you could have it decreasing, kind of like this, your data points. Anyway, you get y equals a plus b natural log x, where a is greater than 0 and b is less than 0. Now, so those are two examples. This is logarithmic. Sorry, didn't write that in. And this is logarithmic. And then it could be linear. You could just have your data points like making a straight line like this. So that's a linear type, whoops, that's a linear type function. Get my linear function in here. And linear ones are great, but not everything's linear. Where y equals, ax plus b, and a is greater than 0, that has a positive slope. Or you could have something that's constantly decreasing at a certain ratio, and so that would be also linear, but a is less than 0. All right, let me write that in. Same equation. Okay, so there's 6 of them, and it can be tricky sometimes to know which one it is. Some of them look alike. One thing you can look at are the domains. So for logarithmic functions, well, I can't spell logarithmic. For log functions, your domain has to be x greater than 0, right? You can't take the logarithm of a negative number or 0. So it's got x has to be greater than 0. But for the exponential ones, here the domain is all real numbers. So you look at your data and you see, are you looking at what kind of domain? Okay, that might help. All right. So now here we have an example. Between the ages of 1 and 11, the human brain does not grow linearly. Using the data and graph to determine what type, use the data and graph to determine what type of function would be a good choice for modeling the data. Okay, so they give you this data so that age 1, the percentage of the adult sized brain is 30. then it goes at age 2, it's 50%, and then it keeps increasing. You're expecting the brain, as they're getting older, the children are getting older, their brain is going to be approaching the size of an adult brain. Okay. And by 11, it's pretty close. Okay. So they took those data points, 130 right there, and then they did 250, and they did all these data points, and they have this graph. And so what type of model do you think would be appropriate? It looks like it's going up pretty quick, but then it's starting to level off, right? And it's not going to go past 100%, right? Because your brain is only at 100% of the adult sized brain. Okay. Um, so this looks like a logarithmic function. And it's increasing. You could say it's modeled by y equals a plus b natural log x. I think they just want you to say it's a logarithmic function, but you could put more information in if you wanted. I think that's it for that video.